Okay, welcome everybody to the webinar today. We're just going to get started in 1 minute, let people have time to filter in, and then we'll kick off. Great. Okay, let's get started then. So yeah, welcome everybody to this webinar with Encord and vialytics. The title of the session today is Future of Smart Cities Inside vialytics AI Data Stack. My name's James Clough. I'm the VP of Engineering here at Encord, and I'm joined by Friedrich, who I'll let introduce himself in a second, is the Director of Data Science at vialytics. So yeah, in terms of the session today, we're here to talk about not just vialytics and their social impact, and they're helping to build smart cities. Friedrich's going to tell us more about what that means concretely in just a moment. But we're also here to talk about the business outcomes that the data stack that vialytics have built over the last few years have helped to drive. Whether you're doing AI for smart cities or an adjacent space, or really any other sector where building a data stack is critical to making sure that your product works the way it needs to, it's hopefully going to be something useful to learn today, mainly from Friedrich rather than from me. But yeah, to begin with some introductions. So I'm the VP of Engineering here at Encord. My background is primarily in AI research. As a leader of a company then building out in the legal space, and now leading the engineering team at Encord, where I've been since the start of this year. And yeah, joined today by Friedrich, who I'll let give his introduction.
Yeah, hello everyone. My name is Friedrich. I studied initially mechanical engineering and then pursued my PhD in computer vision and deep learning together with vialytics already. So that was, I think, 7 years ago. And then I started vialytics as a working student, and I'm now the director of data science leading the small data science team at vialytics.
Super. So yeah, what are we going to discuss today? So we're going to start by going into a bit of detail on vialytics, what the product is and what the mission of the company is as well. We're going to discuss their technical journey from a smaller company with the kind of AI ops challenges that small startups trying to build big data sets often find. And then going to do a bit of a deeper dive on some of the particular challenges to their space, some of the edge cases and the variations from building smart cities in different geographies that they've had to deal with. Plenty of time for questions at the end as well. And we're also going to be launching it through a few polls throughout the webinar as well to get your opinions on some of the issues that are being raised too. A quick introduction before we do that to Encord. So who are we and what do we do? So Encord is an AI data platform. We're here to help you manage, curate and annotate your AI data. And we're doing this to enable you to automate the process of data preparation so that you can build high quality data sets for training AI systems. We're a multimodal platform, so we support image and video, we support audio, text, documents like PDFs, and also now data from physical AI systems such as robots, drones, or autonomous vehicles as well. And our goal and our product supports this process end to end. So we're here to support start of the process, which is data indexing and data curation, helping you find the right raw data from the large amounts of unstructured data that you have access to. We're here to help annotation, so building a slick and efficient interface for multimodal human annotation across all of that data. And also here to support model deployment and inference time learning, active learning, helping you debug errors with your deployed models, helping you find edge cases that are appearing in production, and helping you continually improve performance of your deployed AI systems by learning from what they get right and what they get wrong and acquiring that human feedback. But enough about Encord. We're here really to talk more about vialytics. So got a short video from some of the problems that you're trying to solve, Friedrich, but tell us a little bit about vialytics, what the mission is, and what's the problem that you're solving for cities around the world.
Yeah. So to introduce vialytics as a system and as a product at all, so we are providing infrastructure analytics for municipalities, counties, cities. So we provide as a web system. So our system is we provide a service basically, and our users have smartphones installed in their cars, and they use them basically as you would do when you were using Google Maps. These smartphones can collect all type of data, accelerometer data, but mostly image data. And this image data is analyzed by my team and myself. And then the results are displayed on the web system, where we can highlight damaged road parts, where we can highlight the different types of damages, and also analyze and map general infrastructure or inventory that they might have, for example, traffic signs, or now the latest feature is damaged lane markings, which was actually built already with Encord's software.
Nice. And talk to us a little bit about the mission as well. You know, what does the smart city of the future look like that you're helping to build with this product?
So we see in general a really shortage of time and skilled workers being able to tackle all these different tasks in a municipality. Larger cities may still have specialized services only for roads, but especially in smaller municipalities, it's merging together, it's getting mixed up. One person in the end is basically running the maintenance of the whole city. And if you have a county or a city, you may have a specialized person only for roads, but this person as well has a huge road network. And time, on the other hand, many people are working on this, people on the field, and they need to be connected, they need to be informed, and vialytics is closing this gap. So this is a platform which has a lot of information, able to share this information over all participants. So workers out on the road, which can get tasks on their smartphone, work off this task, document it, and check it off basically. And the people in the office who can distribute tasks, who see the results coming in, and which who can really also over time track the progress they've made in the, for example, in the state of the overall road network, or in the amount of complaints coming in.
Nice. So would you characterize the sort of the value add at the end of the day to the citizen of one of these cities or municipalities is that the sort of the fixed budget of time and people and money that their city had is now actually being applied to the right place, or being applied much more quickly?
It's made possible at all. So many municipalities just struggle to get an overview. If they have an overview, it's usually concentrated in one person's mind. And that person just knows every road by heart. And if that person retires, good luck with that. So vialytics just serves at this one place, this nearly a digital twin of a city, for people to actively collaborate in with another and to do planning and to see outcomes of plannings. So we enable smooth collaboration within a city.
Nice, nice. What are some of the most challenging technical problems that you have to deal with here? Is it primarily this sort of computer vision problem of detecting road damage or other sort of visual signs of damage using smartphones, or is it something else?
So I would say a lot of the product is not just computer vision. It's basically my main domain, but also about making data tangible, making data actable upon. But my biggest challenge is definitely, I love them, but also our customers. They are my biggest problem because they have full control over the data collection. And we need to ensure that the customer has the lowest possible amount of effort to collect data So data collection needs to be really effortless. Otherwise, it's just not done. So they need to be able to take data and collect data under any circumstances. And our goal is to adapt to all circumstances. We ask them nicely to only drive at daylight and to only drive when it's not raining and there's no rain on the windshield. But we need to be able to still robustly catch these cases and work through extreme bright sunlight and then back to shadow. So high contrast, driving really fast, driving too fast for our cameras to take sharp pictures. And I think this is the biggest hurdle for the AI, to be able to work with bad data in the end. I mean, the images you usually see online, on LinkedIn, whatever, they are images that are really
They're like this video.
picture
It's a nice
perfect.
day, it's a good camera. Yeah.
Exactly. They are picture perfect, they are sharp, they look good. But if you really get out there and collect data, the data looks bad oftentimes. And the art is to still produce a good output, even though the data looks bad.
Yeah, absolutely. And maybe just before we move on, can you give us perhaps an example of a way in which you found vialytics has like really helped a municipality or a city do something that they just couldn't do before?
So oftentimes we get the feedback that if they fight for funds, so specifically the planning bureau for the maintenance things, for the road maintenance, they oftentimes get to the city council and ask for funds to repair certain roads. And always the counter question is, why this road? Why not another road? Sometimes the road where the mayor lives is proposed, and sometimes other roads where a really motivated citizen lives are proposed. But this just gives a very founded and grounded information base to enable the people in the bureau who really work off. They really work hard. They want to have a thriving community. And sometimes they're just blocked by this lack of arguments why this road over another. And with vialytics, this can be provided easily. So I think this is a very broad thing. A small anecdote maybe is they were also able to win legal cases because of the images that we had. They could prove that a construction company has destroyed the fence, for example. So the fence was intact before they had the construction site, and afterwards they could document it with the images that they were at fault, or getting warranty for road repairs. Because believe it or not, if there is a company doing a road repair, they are liable if they do a bad job and if the, for example, inlaid patch deteriorates faster than it should. But good luck tracking this over 5 years. So with this software, you can really still claim this, in theory at least, after some years.
Nice. Yeah, that's a nice example. Cool. Well, let's maybe move on to talk about how you actually do all of this. So perhaps to go through things, how they used to be and how they are now. Walk us through how you started out managing your data, your sort of AI data and training data at the start of this journey, perhaps before you'd adopted Encord. What was your setup there, and what, if any, were the challenges you were hitting or the bottlenecks you were facing?
So in the really early days, we were actively working with GPU laptops. So me and my colleague at that time, we both had I think it was a 2070 GTX in a gaming laptop. We spent a lot of time installing Linux on this machine because the GPU would always crash, and then we spent twice the amount of time to get TensorFlow running, which is not a problem today at all.
Installing CUDA drivers and uninstalling them again.
Never gets old. I think Conda really does us a big favor to actually fix that once and for all, or in most cases. And the data that we had was collected in our own backend. So we had an annotation or a QA team we still have a QA team that supports us with data collection and fixes issues in the backend. And they were in the beginning annotating all images. So we did not have any algorithm when we started, and we just had the QA team basically providing customer data, because let's be honest, in the end, the customer does not care who the data was checked by. So we were only delivering manually create data in the beginning, and the customer base was growing this fast that we needed to come to a successful algorithm.
Yeah.
But this mode is just not sustainable, really, because when we wanted to include, so it worked out, we were able to produce an algorithm, but every time we wanted to extend the algorithm by a new class, for example, we needed to implement this in our own backend, because obviously it had a fixed list of classes, which was a huge hurdle. And oftentimes we had to wait as data science team a long time until the dev team really had time to implement this for us. And the data that we had to train on was stored on folders on our nice and shiny GPU laptops.
Yeah.
And it was going quite a while like this. And if we want to change something, it would always take a long time. For example, we would find a wrong annotation in one of the images, and then we would have to go to the folder, look up the label, find the label, and correct the label based on text in this file. It was really very cumbersome. I think the next biggest breakthrough that we had was when we moved to AWS and really started using SageMaker, having a lot of compute on our hand, being able to compute in parallel. I think that was one of the biggest things. And after a while, we found that just always waiting for the dev team is not really sustainable whatsoever. So we had to get our own annotation solution, and we decided at the time to go with CVET and self-host CVET within AWS and upload data to this server and download data from that server again.
Yeah, nice. Yeah, so big bottlenecks there. I think we've also got a first poll we can launch now where we'll ask what are the biggest bottlenecks that other people have hit out here as well. So you sort of launched then CVAT, the self-hosted version there. That's often a thing we hear a lot from people in this space, that they start out with either a self-hosted open source tooling or something that has been hacked together quickly. Perhaps in the era of vibe coding now, that'll be often the way people will start out. Some tool that can be built and sort of does a decent job at small scale, but then as the scale of the data pipeline and of the annotation process gets larger, having to sync multiple devices, or having to sync several labelers or annotators all working at the same time, can start to become a problem and tough to scale. So maybe let's talk about that scale that you guys have to deal with and where problems start to appear. Tell us about, first again, give us a sense of the scale of the data that you work with vialytics, and how has that changed over time?
So it obviously depends really on the type of algorithm. We have way more images for image classifier, for example, than for object detectors. But generally, we really tried different computer vision algorithms, like different types of object detectors, different type of classifiers. But what we really see time and time again, every time we spend a lot of time and effort to make something else run, it barely matters. What really matters is the dataset size and the dataset quality. And to be able to handle that, we lost countless hours of labeling due to CVET crashing. We really needed a more consolidated solution for our data. And that's why I decided to also reach out to Encord as one possible solution for us.
Yeah.
And there is just, if the data set reaches a certain size, it is untangible within a folder. We were at some point just having zip files with I don't know, millions of images that were just churned off by some computer algorithm. We computed scores, we had nice test sets, we see the scores in weights and biases, but you lose the feeling for the data itself. And every time you want to retrain an algorithm or change something, you need to get the zip file downloaded to some machine, unzip it, prepare everything. Just if you want to revisit some examples that you may had in the past. And this is now just this gap that really is closed by Encord, where we have our data persistent and interactable at all times. If we launch an algorithm, a key point that we need to check off before launch, for example, is to run a stress test, which is kind of just simulating the customer experience, not the test set. The test set has worked before. Now we want to see if we just process a month worth of data, what does the customer see? And we had a separate instance where we would run different viewing algorithms or viewing software to view these, but if you reboot it, it's gone. And now we just have the data set. We have the test data set where we can see the results, the scores. We have the stress test data set afterwards, also in Encord, and be able to share this also with the product managers to give them a feeling. How will the algorithm feel? How do I need to include this into the web system to make it workable? It saves so much time. And every time that, for me, I think this was the biggest downside of competitors of you, when they were also able to show data sets, for example, but if you find a mistake in your data set, you need to fix it. I see the mistake, I need to fix it. And this is so nice with Encord that you have this combined power of being able to have your data there, statistically viewable, interactable, and then also being able to annotate it on the fly and correct issues if you see them.
Right. Okay. And it makes sense that pain point grows as the scale of the data set grows, because if you find one issue that needs to be corrected and then you need to move to a different place and search through 1 million images or 10 million images to find the right thing that needs correcting, that gets more difficult. And you also have to do it more times as you have more data as well.
100%. And at some point, the folders will just not load if you have 1 million images in them. It's really a pain to just open the folder. If you misclick somewhere, it's crazy.
Yeah. And just to talk a little bit about the annotation process use. So who are the annotators in your images? Do you have sort of in-house experts? Do you bring in third parties? And how do you ensure high quality there?
So initially, we really just had one annotation step because the self-hosted CVET instance is just not capable of more.
Yeah.
But with Encord, it's now really possible to have designed workflows where we are really able to have a 2i principle. And we really need that. Our data is, as I said, not always the highest quality, and it still needs to work. And especially if you want to distinguish between different types of cracks. Where starts the end crack? Where ends the crack? Is it more a flaking or more a pothole or an outburst? I think these are just decisions that are very hard and difficult to make. And now that we have review pipelines in place, that we can easily select dubious labels. So we oftentimes run our algorithm against our training data set and see where there's high unalignment in between training and what the algorithm has learned. And then we can review these images specifically and being able to have this really adaptable annotation and review pipeline is very, very helpful for our data quality. So I think we really improve with that as well.
Yeah, yeah. Yeah, so we'll talk about data quality and edge cases in a moment. Perhaps now's a good time to launch our second poll, which is about how those listening have handled edge cases that are challenging to label in their use cases too. So thinking about the sort of consolidated pipeline that you're trying to build. So would you say that the decision to build that new pipeline, that was primarily driven by scale? I suppose, can you sort of quantify the change for us in terms of throughput or size of the largest data set that you can handle, or what are the metrics that you care about when you think about this change?
I think we were already at a scale where we could not really work with the data sets efficiently that we had anymore. So for me, the reason why we went to Encord is not really that we scaled even further, but that we were already at a scale where we needed that.
Yeah.
And where we are now fine. So for example, we still have the annotation tool in the backend to review images. And if a customer complains about a certain image, we can act upon it in this image viewer. And this data set just grows stupidly, I would say.
Yeah.
There's no intent. When we retrained, we were not able to further improve really. And I think we just reached a point of saturation where just collecting any type of data is not enough anymore. And this is now the point where we really want to use Encord to build one very high quality data set. And by having this data set in Encord separated from production data and able to really filter and curate it, we can build this static and controllable data set over millions of images.
And what does your sort of model development lifecycle look like? Is it that you sort of build a data set, train a model for one use case, and then that's just deployed, or do you have some continuous improvement process going on in which you're changing your data set, perhaps changing the models as well, and redeploying or reevaluating?
Yeah, so usually every model just starts with the general feature requests that we get. Hey, we need to know about this, we need to know about that, and building the first data set, getting a sign of life out of the data set. So that is basically working, and then scaling it up is the first step where already Encord comes in nicely with being able to iteratively change labeling rules and adding more and more data once it works. But once a model is running, we usually don't touch it for some time. So to have it really a resting period.
Yeah.
And there were models that we did not touch again, which were just running so stable that we did not need to adapt on it. But for example, the traffic sign classifiers, there are just so many different signs out there that it was inevitable that we would have some false positives where a traffic sign that we wanted to detect was confused with a sign looking similar than the sign that we actually wanted to show. And this just needed time to collect more data and then act upon these fails specifically.
Yeah, nice. Well, I think that takes us nicely on to what we were going to talk about next, which is some of those challenging edge cases. So certainly one place I could see those arising is what we see here. You have different geographies and maybe signs that look very similar across different countries, might mean the same thing or might mean a different thing, might need to be classified in different ways. So how do sort of road conditions and infrastructure vary across the different geographies in which vialytics is deployed, and how do you handle that challenge?
So we learned that balancing out data sets, especially for traffic signs, is very, very important. So we run different algorithms, basically unified for all countries. The traffic sign classifier is separate for every country. So we have one classifier for Germany, France, and for the US. And other algorithms that are running for example, damaged lane markings. We were able to detect if a lane marking is damaged, but lane markings as well look different. For example, France has many different texts also written on the road surface. And these edge cases were hard to get right in the beginning, but through balancing and selecting these specific outliers, we could kind of catch them back in. So data balancing is very important, very important.
And do you sort of work to identify sort of gaps in the data distribution that you have, perhaps illustrated by problems the model has, or do you sort of take an approach where you just try to sort of sample evenly across the distribution of roads that you care about?
We make sure that the test data set is equally distributed, and if we are unsure if there's a strong bias in the data based on country, we also evaluate the test data set once, like overall, and then also basically set by set. That's really nice to get a feeling where the weak points are, and then oftentimes we react upon, right? In the beginning, we sample equally, we build data sets that are equally distributed. But for example, if we see oftentimes Germany and France are more similar than the US, and then we go on basically and add more US samples to the data set and grow it step by step until these weak points are found or are not appearing anymore. So we upsample basically on demand.
Yeah. Okay, interesting. And I suppose as well as the distribution of the raw data, you also perhaps have to worry about the distribution of the labels as well. There might be certain cases where your annotators encounter something rare in terms of the task they're doing, and they need to share knowledge there. What's your approach to ensuring that all of your annotators have the current best practice on how to handle some of those challenging cases?
We create label rules first, and these label rules are shared with the annotation team. They start labeling the first 100 images or something like that, and we have one person from the QA team designated as reviewer for that project, someone who has proven to be a good reviewer already, and someone from the data science team. At least one person from the data science team reviewing, at least in the beginning. And then we continuously improve the annotation guidelines, because there's always something you cannot predict in the beginning. And then at these edge cases, get clearer, get better guidelines into the label catalog. Since it's the same team and they are already really practiced in this type of task, we are able to let it go at some point, where we can trust, okay, they really got the hang of it, and they can communicate over separate channels. And what's also nice is the review functionality in Encord, where you can leave issues and remarks.
Yeah.
Because oftentimes even the reviewer is not sure what's right here. Yeah. So sometimes when I'm reviewing, sometimes I'm just giving like a recommendation back and asking, hey, have you considered this? Would you still say it's this case? And then it may come back unchanged with an answer, yes, I'm 100% sure. And oftentimes this way you can really get a feeling for the data when you later train the model and really understand the problem, which is very helpful, and find these edge cases in the annotation guideline. But balancing different test samples, I found, is not necessarily super important, because in the end, you also want the model to understand how real life distribution looks like. Yeah. So having a distribution in your training data similar to what's actually out there is not that bad. Knowing obviously the distribution and maybe adjusting class weights can be helpful.
Yeah, that makes sense. And presumably you find that I can imagine there are some models or some use cases where pooling data across geographies makes sense. Road damage.
100%.
Maybe it's road damage
Yes.
in every country that, I can't tell whether that's a French pothole or an American one, but a sign that's incorrect might be very specific to a geography. And so in those cases, do you sort of build a specific collection or data set using this kind of, like what we're seeing here, and then go and train specifically there?
Yes. For example, for the road damages, we have one unified model. What we've learned so far is that providing models with the maximum amount of information at the same time is beneficial, and having this this global view on road damages is helpful, but there are differences in between German, French, and US roads. So the model really benefited also from incorporating US images into the training data, even though the differences are not that massive as traffic signs.
Yeah, super interesting. Cool. So we're getting towards the end of our time here, but it'd be really good to discuss, Friedrich, what the future looks like for vialytics. I know you're a fast growing company, and there's got to be a lot of opportunity out there for new things that you could be doing. But what would you say is next for you, the company, and for the sort of smart city space more generally?
I think with the rising of multimodal AI, we also see a lot of potential there. So from my data science perspective, I would love to see a future where we would be able to have our customer just type in, I want to see where my traffic lights are. And we can just unlock this with one snap. Just because we already maybe computed clip features or have pre-computed all features that we can match with this text query, and just be very fast and very flexible to the customer demands. And also running multimodal AIs on our image or on our evaluated data and ask them for input and feedback, which would further build upon this. How can we ensure that workers in the city are able to keep the knowledge base with them? If one experienced person leaves, the next person may never have worked with roads. They need to work with the people they have, and they will be motivated, but they may not have the experience to really make a decision for the roads. And I think with one unified knowledge base and strong agents that can work as counselors or consultants in this regard, that would be very, very futuristic.
No, that would be exciting. Going to open up to questions that anyone in the audience has for Friedrich as well. While you're typing those in, maybe one last one from me is, what advice would you have, Friedrich, for other companies at a similar stage to you, or perhaps a little bit earlier, who are starting to try to scale their ML operations? Maybe there's somebody listening who also has that self-hosted CVAT implementation and is encountering some of the problems you have. Like, how should they decide what to do next?
So if you're really at the stage where you're self-hosting CVAT and you have no funds, automatically restart it and always save your results. Otherwise, I think another hosted data platform is really the way to go. For our data science team, it's a central place. The first thing we open when we work, gives us a lot of control. I think this is a really underrated feature from Encord, that you're able to estimate how much time will it take to get a data set. And if you compute scores on chunks of your data set, you can also estimate how much images you will approximately need to reach a certain performance. And this gives you a lot of control over budgeting. I think this is at a stage where you have reached a certain maturity. Still, if you're really early, I would say focus on a diverse and realistic test data set, and always do a stress test before you launch. Otherwise, your results will never look or will definitely look different than what you've expected.
Yeah, will definitely look different and usually worse. It's very, very rare that you've happened to get the other way. Yeah. No, so we got one question here from Chris, who asks, what do you think infrastructure management, like you've shown us today, will look like in 5 years' time?
I think in 5 years, the whole process of organizing road repairs will be way faster and way more flexible. It's already done now with a lot of contractors that need to apply for certain construction sites. I'm more familiar with the German side, so there's a lot of bureaucracy around this. And I think in 5 years, you will find something to fix in your city, really automated by just driving by it. And you will be able to kind of send out requests to fix this, and contractors who are not, or contractors who would be willing to do it, can accept the job. It will be automatically be shown to the municipality that this job was accepted, paperwork, documentation, all included, and they can just get to work and not waste hours of time to handle paperwork.
So just sort of one platform where the work that needs to be done is automatically recognized and jobs created, and then the people who need to do it can just say,
yes,
just bid and accept that work. Great, I'm just going to go and fix that pothole right now. Accept.
exactly.
Sign.
So basically, you would drive by the pothole, it is recognized, put into the web system, and you can say, my own construction workers should fix that, or put it out to any specialized company that you wanted to fix. They would all get a notification and just fix it, and all documentation, paperwork regarding this would be taken care of already.
Yeah. Well, if anyone from the Mayor of London's office is listening, that'd be a good idea. We should do that. Will make my life better for sure. Question from Annabelle. She says, what's been the biggest surprise that you've had working with real world road imagery?
So our customers oftentimes drive with cars, and oftentimes the car hood or the trunk, no, the front of the car is in the picture, and we don't care about the front of the car. So we crop that out to speed up processing and to not waste time on. Sometimes we found reflections of traffic signs on the car hood. A really nice polished car hood, but obviously we don't care about reflections.
Yeah.
And we have built a built-in uncertainty mechanism. That uncertainty mechanism alerts the quality assurance team to fix any viewport or bottom or kind of lower crop of the image that is unsure. And this model was working so well until someone was deciding to drive with a sweeping machine, and you would have these brushes in the front, and the model was just this, and the next one was driving with a tractor, like a land machine. There's no lack of surprises. People will just always come up with something to surprise you. Like our models are just, there's just so much complexity in our models, but the reality is infinitively complex.
Yeah, because the reality is you've got to handle all of the stuff out there in the world, right? And that can
everything.
That can be all sorts of different stuff. Super interesting. Look, we could ask questions all day, but we've reached the end of our time slot, so we'll have to leave it there today, Friedrich. But thanks again for giving us your time and coming on to talk about what you and vialytics have been up to over the last few years, building out that scalable data pipeline and building the smart cities of the future, and some of the interesting stuff that you've got coming forward as well. Maybe we'd have time for one last question if you have, Friedrich. Just come in from Ashwani. He says, what features in an annotation tool have you found to be absolutely critical for road seasons? Most important features for annotation?
That's a really good question. I think it is not so much about the actual annotation capacities. So obviously having a brush, having a polygon tool to do masks, having bounding boxes or having classifications, this is all nice to have. But I think the real game changer for me is being able to set up a workflow that enables you to have good quality data and review, because the images are bad quality, they are uncertain, they are unsure, the people need to be aligned on what they're labeling, and being able to have multiple stages and really review this critically is the number one thing that is crucial.
Nice. Glad we had time to squeeze that one in. Hope that answers your question there, Ashrani. Okay, thanks again, Friedrich. Let's leave it there for today. But really enjoyed the conversation. If what Friedrich's told you sounds interesting, you think that Encord could be useful for you, then go to our website, check out the demo, explore the product, and hopefully, whether you're at the same stage the vialytics are at, a little bit earlier, a little bit later, there was something interesting to learn today. So thanks again, and see everybody hopefully next time. Bye now.
Have a great day.
And you.
Bye.